Assalamu alaikum. Today the topic on which I will discuss about you is implementing the logic of different types of adders on Verilog HDL Quartus, and the previous video was about the same topic, but we did it on Proteus, and that was for half adder, half subtractor, full adder and full subtractor using NAND gates and all the other gates. But today our topic is only restricted towards adders, and so let's start. First of all, we know that in electronics an adder or summer is a digital circuit that performs addition of numbers. In modern computers, adders reside in the arithmetic logic unit where other operations are performed. Although adders can be constructed for many numerical representations such as binary coded decimal or excess 3, the most common adders operate on binary numbers. In case where 2's complements is being used to represent negative numbers, it is trivial to modify an adder into an adder subtractor. Now there are types of adders. We have an half adder in which we have two inputs, two outputs. Two outputs are S and C. S is for sum and C is for carry. S is the 2-bit XOR of A and B, and C is the AND of A and B. We have already did this in the previous lab. You can search there, TLD lab number 8. And the second type of single bit adder is the full adder. The full adder takes into account a carry input such that multiple adders can be used to add larger numbers to remove ambiguity between the input and output carry lines. The carry in is labeled C1, CI or C in, that is carry in, while the carry out is labeled as CO or C out. When multiple full adders are used with the carry ins and carry outs chained together, then this is called a ripple carry adder, because the correct value of the carry bit ripples from one bit to the next. Now if we look that how can we implement the logic of different types of adders. So first of all, we can view this example number 1, in which an Verilog code for an unsigned 8-bit adder is present. First of all, if we see that here, we can see that first we have made a module. Inside Quartus, first you have to make a new project wizard, select a new file of Verilog HDL, and then do the coding. First of all, if we want to make an unsigned 8-bit adder, then we can see here that first we have to make the module, and the module name should have a same name as the file name, and then we have given some inputs and outputs, or we can say integers. So first two A and B are given as our inputs, the output is given as D is for sum of A and B. Then we have assigned D is equal to A plus B. So, and then we have end the module. So here we can see its RTL viewer, RTL sketch that we have above. In this code we can see that we have given two inputs. These are our two inputs. Then we have made an adder by our assign values, that was assigned D is equal to A plus B, and so this is our output, D is equal to A plus B. Now, and similarly this is our graph. I hope you can see this. Let me zoom in for you. If we see that these are all are our decimal values, so these three graphs and these three codes are same, so don't worry about that. If we see that the decimal number given at A is 25 and at B it is given as 102, so D is equal to A plus B, that is 25 plus 102, and the answer is 127. So our output RTL viewer and the code is absolutely perfect for example number 1. That was our example number 1. In example number 2, it states that write the Verilog code for an 8-bit unsigned adder with carry in. That is, this is for a full adder inside which we have a carry in. Basically, a carry in we have discussed in the lab 8. What is carry in? You can view there. So now we shall see that in example number 2 it is saying that we should add a carry in as well. So we have made a module. The module name is same as the file name. These are our integers, and we have 3 inputs. We have input a carry in, and A and B are our 2 inputs, and output will be our sum. Then we have assigned sum as A plus B plus carry in. Then we have end the module. So now we can see its RTL viewer. This is our RTL viewer. So since we haven't given any value like this 70 to carry in, it is just it doesn't have any value here, so it will be added direct towards this adder, as we can see. And these two A and B have this adder, so one of the terminal of this adder will be the addition of this A and B, and one of our terminal of this second adder will be carry in, and this will be our output carried as sum. And now if we look towards our sum, so here we can see all of these values are in decimal value. So when our carry in is 1, our B is 1, and A is 1, all of these 3 values are 1, then our sum is 3, as we have assigned here the value sum is equal to A plus B plus carry in. So now let's carry on towards another method, that is example 3. Now we shall see what is example 3. It states that write the Verilog code for an 8-bit unsigned adder with carry out. Now it is saying it that to write the Verilog code for an 8-bit unsigned adder with carry out. Example 2 was with carry in, example 3 is with carry out. So now let's see. This is our code. First we have made the module, and instead of carry in we have taken an integer named as CO, that is for carry out. So we have 2 inputs that are A and B, and in the example number 2 we had 3 inputs that were A, B and carry in. In the third example we have 2 outputs and 2 inputs and a wire. So 2 inputs are A and B, the output is sum, output is CO, wire, and we have assigned wire as the addition of these 2 inputs. Then we have assigned carry output is equal to this wire, and sum is equal to this wire. So now we shall see our RTL viewer. This is our A and B, which we have assigned, which we did addition through a wire. Here is our wire, and here we can see the assigned values that were CO is equal to WR, CO is equal to sum. This wire that was assigned is giving us these 2 outputs through these addition. So now we shall continue towards our next example, that is example number 4. In this example we have to write a Verilog code for an unsigned 8-bit adder with carry in and carry out both. So here we can see that we have made a module, and the file name here we can see that it is lab number 9, and then we have 5 of our integers. We have input, we have given inputs to CI, that is carry in, A and B. We have given outputs to sum, CO, and wire we have given as temp. So we will then assign temp is equal to A plus B plus CI, and the sum will be equal to the value of temp, and similarly the CO will be equal to the value of temp. Basically the example 4 is just a combination of example number 2 and example number 3. So if we look at our RTL viewer, it is same as the example as it is, we can simply say it as a combination of the example number 2 and example number 3. First we add 3 of our 2 of our if we see that we have added our two inputs that are A and B through an adder, and we and the single input here for this adder is given through carry in. This was carried out in example number 2, this was carried out in example number 3, and this same value expression was carried in example number 3. So this is just all the combination of example number 2 and example number 3. So here we can see our output waveform. We have made the carry input 1, carry output 1. So and A plus B, we can see here, this is our added value. These are all in binary values, so you can calculate yourself that whether these values are correct or not. I have already checked and these values are correct. And now we shall go towards the example number 5. Inside example number 5 we shall see that we should write a Verilog code for an 8-bit unsigned adder subtractor with carry in and carry out, and we have to use a selection input to select between addition and subtraction. So this is our code for that, in which we have 6 variables and 4 of our are inputs. That is the fourth input, which we can say that we have added from the example number 4, that is for selection line. And then we in order to see that whether when selection line is equal to 0, then this process will carry out, and if selection line is equal to 1, then this subtraction value expression will be carried out, and if s is equal to 0, then addition will be carried out. So from the RTL viewer we can see this is our RTL viewer. So from this we can see that when we add a selection line with carry in and carry out inside an unsigned 8-bit inside an unsigned 8-bit adder with carry in and carry out. So that's how its RTL viewer is made. And here we can see our waveform. When our C out is 0, then our sum will be 0. It all depends upon, as we can see here, this value is 0. Why it is 0? As we can see here, when our C in is equal to 1, when our selection line is equal to 1 and these two values are same, so here we can see our subtraction is carried out and the value given to us is Z is equal to A minus B, that is 0 0 0 0 0 0 0 0. These are 8 zeros, and similarly the other ones. And this was our exercise in which we have to construct and implement the logic of a 4-bit ALU. The ALU should contain at least 10 functions given below in the table. Please clearly state all the functions that you will use in your Verilog code. Basically in this exercise code we had to made a 4-bit ALU, and the functions that it should perform were addition, subtraction, multiplication, division, modulus, greater than, less than, or, and NAND. And then we have assigned all of these functions as add is equal to A plus B. These are our two inputs, and subtraction A minus B, multiply A multiplied by B, division A divided by B, mod A percentage B greater, A should be greater than B, less, A should be less than B, or A or B, and A and B, and NAND. negation of A and B, and then we have end the module, and this is our RTL viewer, and this is our output waveform. If we have given A is equal to 39 and B is equal to 19, then addition will give us 58, division to greater than this, less than this, modulus 1, multiplication 229, subtraction 0.15625, and this value is not in decimal, so don't worry. Basically it will give us 20. So that's all from my side today, and we have done our lab number 9, that how can we implement an unsigned 8-bit binary adder or a 4-bit ALU, and different implementation of these adders inside Quartus Verilog HTL. I hope you liked the video. Thank you, and Allah Hafiz.